Today, as we looked at our bell work, it's supposed to be a review of different properties of exponents, and so we need to be sure that we have those. Don't just put those away yet. We'll need them in a few minutes in class. But we're going to be looking at some properties of logarithms, additional properties of logarithms, such as change of base property, expanding logarithms using some of our expansion properties, and then condensing logarithms. And the last two are a lot of the same idea. Up to this point in time, we've not been able to evaluate things like log base 3 of 17. We don't have a way to put that in our calculators. And when we introduce this change of base rule, that gives us then a way in order to find that missing value. So that's what the change of base rule is about. So we have a log base b of some value x. I'm going to write this for a generic base, and then we're going to look at it for the two bases that we'll probably use most often. This becomes the log of the new base a of x over the log of the new base a of b. So change of base, new base is here. The value of the logarithm is on top, the old base is on the bottom. Again, a lot of us would probably see this as log base 10 or common log of x over log base 10 of b, which is common log of b. Or if we want natural logs, either one. Any of those three are telling us the same things. Again, we use these because that's what's on our calculators. Questions about that?
So we can use the natural log or the
Common log base 10?
Okay.
Yes, we can use either one. In fact, let's have an example of that. Like I mentioned a minute ago, let's think about the log base 3 of 17. Now, before you just start punching numbers in your calculators and try to figure things out, let's look at this for a second. Remember, this question is saying 3 is raised to what power? And that answer then becomes 17. I know that 3 to the second power is, and 3 to the third power is, so that means my answer I'm expecting should be somewhere between 2 and 3. Because 3 to the second is 9, and then we go 27. So somewhere between there. It's probably in the neighborhood of about 2.5. So now let's plug it in and find out. So let's use the common log first. And let's see what we get. And I want 3 decimal places in here. We get an agreement with that? Okay, and that was our common log. So as mentioned, let's take a look at our natural log. I'm going to predict that it's 2.579 again. That should not have been a surprise. Questions? Yes.
So it's asking what to the 3, what to the power of 3 equals 17. Why can't you do like the square root of 3 with 17 inside the radical?
Well, the square root of 17 is about 4.1, which is a little bit more than 2.57.
No, like when you have the 3 on the outside, and it's like the third root.
All right, let's do this. Remember that the log base 3 of 17, if we make that equal to y, that means 3 to the y power is equal to 17. So my question is, what value should y take on so I know what particular radical to use Is it the third power? Is it the second power? Is it the fifth power? So do I use the square root, the cube root, or the fifth root? And because I don't have a particular power here, I don't know what particular root to use to find this value. And the value of logarithms is saying, okay, now I know the particular root to use, because this problem tells me then that 3 to the 2.579th power, and if you put that in your calculator, again, we rounded, so it's not going to be exact, but I bet if you get close, it's going to be pretty close to 17, isn't it? 17.0. Which, if we're rounding, that's probably going to round to 17. Maybe we'll agree that it could be 17. And so the reason for the logarithm is to find that power. That's what it really does for us. But you would be correct, if we knew a power, we could take the root on both sides. That would be a true statement. But this allows me to find what the power actually is. And that's where they come from. Questions about that? Okay. So this is change of base rule. This is part of what we do today in class. You have some homework problems related to this. Some of them are going to ask you to write this statement and this statement related to a given logarithm, and that's as far as you have to go. You don't have to do anything else to it. Please don't read more into those problems than what's there. So be sure you understand the instructions. But the next part of what we want to do is go back and look at some properties of logarithms, of expanding them. They're in addition to the properties that we had last class period. Still going to number 1, 2, and 3. We'll call them expansion properties. You may or may not remember these from last year, and if you don't, that's fine. We're going to add to them again. If you do remember them, then you've got kind of a head start on everybody else.
Is the u, like, it's not a subscript or superscript?
Nope. It's just log base b of u times v is equal to the log base b of u plus the log base b of v. That's what it looks like. I'm going to show you a proof of this, a mathematical type proof, just to kind of help you figure out what's going on and why it's going on. I did not plan to require you to re-show me this proof on any type of test or anything, so please keep that in mind. We're going to choose to let x equal the log base b of u and y equal the log base b of v. Now, if we go back to our definition of the logarithm, can I rewrite x equals log base b of u as an exponent equation? What is it? If you're nodding your heads yes at me. Okay, this is when you dig in your notes and you find this thing. Go dig in your notes.